Okay, hello and welcome to this first lecture in electric motors. My name is Per Marklund and this is a part of the course Advanced Machine Elements. What we will do here is to give an overview of electric motors from a mechanical engineering point of view. We will not go into detail exactly how they work. We will instead talk about properties that are important for you to know if you are about to use electric motors in a system or a machine that you are designing as a mechanical engineer. So, electric motors then. What we basically are talking about all the time is a changing magnetic field that makes the rotor with the output shaft to rotate. We have two different main types. We have direct current DC or alternating current AC. And these are also divided into different subgroups, like the DC motors that may have brushes or might be brushless. But the brushless is in reality an AC motor, but I will come to that. Or AC motors have synchronous motors or asynchronous motors. But let's start. The most common DC motor is the brushed motor. A brushed motor has brushes, as you can see here on the figure. The brushes are then through the commutator distributing the electric current to different windings or coils that generates magnetic fields. And in this case you also have field windings. When you talk about the brushed motor, the most important thing is that you have these brushes. They are normally made of graphite. The commutator is made of copper. And when the rotor is rotating, this one will be in contact to different connection points in the commutator, which are connected to different windings. So this is how they work. The brushes are a weak spot. They wear out now and then, and it's often possible to change these. And it might also be sparks that are going between the brushes and the commutator sometimes. The most common brushed motor is the permanent magnetized. It normally looks something like this, which can be found in toys or whatever. It's a mass-produced brushed motor. We can see here in the picture, which is made very simple. Here you can see that the bearings are only bronze bushings. And this is a very cheap type of motor, often mass-produced, as we said, and used many times in, for instance, automotive industry. If we look at the characteristics of this motor, we can see that here we have the torque that goes from 0 to 1. When it's 1, it means that we have the maximum torque for this specific motor. And we have here the rotational speed goes to 0 to 1, with 1 is then the maximal rotational speed for this specific motor. As we can see here, this is in theory. We have a completely linear behavior where we have the maximum torque at standstill and the lowest torque 0 at maximum rotational speed. That's why it stops to rotate any faster. In theory it looks like this, but also in reality it's a really linear relationship. This is important in many machines that you have a high starting torque. And when you have a high starting torque, it can therefore be a suitable engine type in these applications. This is more how it looks like. You can see here are the brushes, the rotor, and one south magnet, one north magnet. And here you can see that they are the same color, which indicates that the rotor is also south here and north here. So this will repel from the stator, and that means that it starts to rotate. And when it rotates a little bit, this will change. So then this part of the rotor will become north and start to repel, and it will continue to rotate. If we look at the power output from the motor, the power is highest when you have 50% of the maximum RPM. The maximum power is here, and we have no power output when we start, because of course the power is torque multiplied with rotational speed. And since the rotational speed is 0, we have a 0 power output. This, however, doesn't mean that we don't have any power that goes through the motor. And since we are consuming energy in the motor but it doesn't rotate and we don't have any power output, everything will go in the form of heat. And brushes, windings may be destroyed at low rotational speed because of bad cooling. If we move on to another type of motors, still DC motors, still brushes, but serial magnetized. In a serial magnetized motor, field and rotor windings, so both the rotor and the stator, has windings, electrical magnets, and they are connected in series. This motor type also works with AC, as in this example, a corded drill. Many hand tools are of this kind. But since it works with both AC and DC, it's sometimes called a universal electric motor, or in Swedish Allströmsmotor. The motor has a predetermined rotation direction which can be shifted by shifting the field or rotor windings. And there also exist parallel magnetized motors which have similar features as the serial magnetized motor. And as the example, many hand tools, simple equipment, and especially the equipment where you need a high start torque. If you go back, you see it has the same behavior like here. So we have a high starting torque, which is of course very important. For instance, in this corded drill. Next type, brushless motors. These are becoming more and more common. A brushless DC motor is, however, actually not a DC motor. It's a permanent magnetized synchronous motor. In other words, an AC motor. This means that they need special regulators or speed controllers to work. So you have the DC power and it goes through the speed controller and gives you a controlled AC signal. They normally have 3 connection cords, which means that they normally are 3-phase motors. And they have very high efficiency. around 90% compared to the brush motor that is around 70%. However, they are relatively expensive, and this means that they are not used very often in cheap equipment. And they are not often used in, for instance, the automotive industry for smaller equipment, like what we said, because they are too expensive. And you can't use them without these high-tech speed controllers. And that's what I was planning to go through in this first session. And if you join me in the next session, we will continue to talk about AC motors. Thank you and goodbye.